Hey, there have been a number of questions about the logic probe video that I made, so I'm going to follow it up with this video and try to answer some of those questions that people have placed in the comments. So for starters, what is a logic probe used for? Well, in the simplest terms, what you are doing is looking at logic signals, highs and lows, on digital circuits with it. You're going to hook it up with these clips to the same power supply as the digital logic circuit that you want to check on. You want to check values. You're trying to debug or repair something, and or you are just analyzing how something works, let's say. So you hook those clips up, and now using the logic probe, you're going to set the switches TTL, CMOS, MIM, and pulse. TTL and CMOS are voltage levels. They tell the logic probe which voltage to consider a high and what voltage to consider a low. In fact, they're voltage windows. Let's take a look real quick at logic levels on the Spark Fun page. TTL logic levels, you can kind of see when someone mentions TTL to you, think 5 volts. And basically what you're looking at here is a high, voltage high, between 2.7 volts and 5 volts. So when you set that switch on the logic probe, you're telling it, hey, this is what I'm looking at. So this is the window that represents a high, and this is the window that represents a low. So you can kind of see a low voltage, 0.8 to 0. Now CMOS is different. Typically CMOS uses lower voltages. So you're telling the logic probe now that maybe between 3.3 and 2 volts is a high, and it looks like it's about the same voltage for the low. So that's what that switch actually does. It identifies the voltage level of the circuit you're using. Memory, I'll address in a second when we look at the manual. I've never used it. Pulse, I have used a few times. Pulse tells you that there's a pulse train coming through. What is a pulse or pulse train? Basically, it's a signal being sent through either serial or typically it's serial. You can have parallel ones too, but the point is that it's a series of ones and zeros in some order for the data that's being sent through, and it's happening maybe so fast that you can't really see the one and the high and the low going. And instead, it tells you, hey, there's a pulse coming through. So with that, let's go take a look at the manual real quick. So there is an English manual on this page. Let's increase this a little bit here. Okay. So most logic probes are the same. This logic probe really lets you look at one signal at a time. If you really get into digital repair or circuit design, you might get a chance to use like a digital logic analyzer, which is on a lot of oscilloscopes nowadays, where you can actually hook up multiple lines, multiple inputs, and see a number of things going in relation to time. So anyway, so what is TTL? Well, this is telling us TTL for this device is 2.3 volts to VCC, most likely. And this is saying it's less than 0.8 to ground. That's what a 0 or a 1 is. And it gives you percentages here because CMOS isn't always 3.3 volts. In terms of frequency response, 20 megahertz. So that's as quick as it can look at incoming pulse signals. So let's look at this chart right here. It's just kind of helpful to understand what's going on. Okay, so if there's no signal coming in, then high and low are not going to be lit, and the pulse. That makes perfectly good sense. If the voltage is a 0, then low will light up. If the voltage is high, high will light up. If the voltage goes from low to high, then you'll get the low and you'll get the pulse indicator. If it goes from high to low, then you'll get the opposite. You'll get the high indicator with the pulse. If the square wave is less than 20 kilohertz, that's the frequency of the signal that you're reading, you'll get both set and pulse. If it's greater than 20 kilohertz, you'll get, looks like they'll blink. These high will blink, low will blink, and the pulse will blink. Now, the memory, I don't really know what the memory is for. It's as you're probing around, you can kind of have it remember what you've just read. So the thing is that you're only reading one thing at a time, and you can hear that it's high or low. We're going to go over to the bench. I'm going to put together a simple logic circuit, and then I'm going to use the probe and show you the values that it's returning, what it sounds like, etc. So let's head over there. All right, so let's talk about our logic probe test. What we're going to do is we're going to build a NAND gate circuit. A NAND gate has this truth table. Think of a NAND gate as an AND gate with the output knotted or inversed. A 0 and a 0 give you a 1 with a NAND gate. 1 and 0 give you a 1, 0 and 1 give you a 1, and a 1 and a 1 give you a 0. So the circuit's going to pretty much look like this. We're going to have two switches tied to ground. We'll have a pull-up. On the IC itself, pin 1, pin 2, and pin 3, 1 and 2, this is 1 and this is 2. Those are the inputs, and the output is 3. Also, pin 7 down here is ground, and pin 14 is VCC. So what should happen? We should be able to follow this truth table. As it is, it's 1 and a 1, so the LED should not be lit. We should be getting a 0 out. Now what we're going to do is just kind of step through these, and then we're going to hook the logic probe up and look at it also. So here is the circuit I actually built. Let's just get our bearings with it really quick. We've got 5 volts coming in. We've got, these are the two pull-ups. They're going to this rail right here, which is 5 volts. The IC, we've got pin 14 is VCC, which we can kind of, maybe see here. Pin 7, which is here, is going to ground. Here is our LED tied to a resistor to output 3, and here's 1 and 2 to these pull-ups, but they're also tied to the switches that go to ground. So when we press them, they go to ground. Right now they have a high voltage on them. How do we know they have a high voltage? Well, let's grab our logic probe. I'm going to hook negative to negative, black to negative. Okay. So, logic probe is in CMOS mode. Just for the fun of it, I'm gonna put it on the positive voltage, and we get a beep that it's high, and if I go to ground, we get a beep that it's low. So if I knew nothing about this circuit right now, obviously I'd be able to look this up, the number on the chip. So we've got an AND gate. So what is the signal? Is it a 1 or a 0? It is a high or a low right now on pin 1. Well, we know it's got a pull-up, but if we didn't know that, we should know that we're going to get a high. Yeah, there we go. We know we got a high because we used the logic probe. I'm sorry, that's what I meant. What about 2? We got a high. What about 3? We got a low. So by having the switch set to TTL, it understands what the range of voltages are. If we were using CMOS circuitry, we would switch it to CMOS, which would change that window slightly. If it was actually pulsating at a certain frequency, based upon the manual, we would hear the pulsating noise. So let's take a look at this for a second. So based on our truth table, right now we've got a 1 and a 1, and we've got a 0 out. So if I press either one of the buttons, I should get a 1 out. Oh, there we go. We got a high voltage out. We got a 1 out. That's the high voltage indicator. So if we put our logic probe there, It's low, now it's high. Low, high. So we should even be able to pulse it. The pulsing light is coming on, both are lighting up, pretty much following the manual that we indicated. Now the only one we haven't done is we haven't pushed them both, so they both go to ground. We should also get a 1. So let's check them. Yep. Oh, that one is grounded. Yep. What about this one? This is grounded. What is that? That's a high. So what you're using your logic probe for is to very quickly analyze a digital circuit to see what's going on with the signals in different states so you can determine if something is working correctly or not. All right, well, I hope you found this video helpful. Keep in mind, you can kind of do the same things with a voltmeter. You just grab the voltmeter and you check the voltages, and in your head you go, okay, well, 2.5 to 5 volts, that's going to be a high. All right, well, I hope this was helpful. Hopefully it answered some questions that you guys had. All right, bye.